So here we have a multi-part question, a typical question that you might come across on your physics exam. It has 5 parts, and the question reads like this: a ball of mass 2.5 grams experiences an acceleration of 1.8 meters per second squared for 5 seconds. If the ball was initially at rest, calculate 1. The accelerating force, the velocity of the ball after 5 seconds, the displacement of the ball after 5 seconds, the work done by the force, and the power dissipated by the source of energy. So we first will have to solve part 1 in order for us to actually solve the remaining parts. So let's take on part 1 right away. So let's say for 1, in part 1 we are asked to find the accelerating force. So to do that, first of all, let's look at some values that we're given. We're given the mass of the ball, we're given the acceleration that the ball undergoes or experiences, and we're given the time for which that acceleration is experienced. So if we're given the mass and the acceleration and we're asked to find the accelerating force, we can consider Newton's second law, which says that the force on a body is equal to the mass of the body multiplied by its acceleration. So this is Newton's second law, so we can use it to assist us in solving part 1. So we're told that, first of all, let me just write down some variables here. So we're told that the mass is equal to 2.5 grams and the acceleration, let's write that ACC, is equal to 1.8 meters per second squared. So we can use these two values here to assist us in solving the problem. But first of all, whenever we're working on problems like these, especially if we're going to express our answer in its SI terms or in SI unit, we will need to actually ensure that the variables or the values that we're working with are in the SI unit. Now the SI unit for mass is kilograms, so I'll have to convert 2.5 grams to kilogram. To do that, I will divide by 1000 and get an answer of 0.0025. So basically I've moved my decimal place 3 places to the left, and this is in kilograms. So I can use these values now. I can use this one here and this one in my formula. So I will say force is equal to mass times acceleration. Force is equal to, the mass is 0.025 kilograms, and our acceleration is 1.8 meters per second squared. So if I call on my calculator here and I say 0.0025 multiplied by 1.8, I get an answer of 0.0045 newtons. Right, so that's my force, which I've just calculated, the accelerating force. So a force of 0.0045 newtons causes an acceleration of 1.8 meters per second. Now part 2 asks us to find the velocity of the ball after 5 seconds. So let's say part 2, let me just scroll up a bit. So we want to find the velocity after, what did it say, 5 seconds. Alright, so we can use our formula for linear velocity, right? And that formula is V is equal to U plus AT, where V is our final velocity, U is our initial velocity, A is our acceleration, and T is our time. So V is our unknown in this case, right? U, let's look back at the question to determine what U is. Again, U is our initial velocity. Now, the question says that if the ball was initially at rest, it therefore means that the initial velocity is 0 meters per second. So U is 0 meters per second. Our acceleration is 1.8 given by our question. So acceleration is 1.8 meters per second squared, and our t is 5 seconds. So we can use these values then in our formula. So let's write v is equal to u is 0 meters per second plus acceleration is 1.8 meters per second squared multiplied by our time of 5 seconds. So 5 seconds. So if we were to plug this in our calculator, 0 plus 1.8 times 5, first of all this will be 0, so we'll be left with 1.8 times 5, and that gives us a velocity of 9 meters per second. Okay, so let's move on to part 3 in the question. Part 3 wants us to find the displacement of the ball after 5 seconds. So we've just found velocity, and so let's write, first of all, let me just write part 3 here. So we're doing part 3 now. We're finding displacement (5 seconds). Okay, so we know velocity is equal to displacement over time, right? So if we know our velocity and we know time, we can find our displacement, right? So we just worked out velocity to be 9 meters per second, and we're asked to find the displacement in 5 seconds. So we can rearrange this formula here to make displacement the subject, and whenever we do that, we'll get that displacement